been inside. But now we're setting them equal to something in order to solve. Yes? Now, this one is a very basic trig equation. It's just sine of x equals 1/2. And we're first going to look at it graphically. For the most part, we are not going to solve these graphically, but I at least want us referring back to our graphs. So hopefully we remember our sine graph. So remember, it starts at 0, 0. We have an amplitude of 1, and we have a period of 2 pi. Yes? Okay. So then notice, what's the other line that we have graphed there? The dotted line? What's the dotted line? And if I want to know where sine of x equals 1/2, what do I look for graphically?
Where the sine graph passes 1 equals 1/2.
What else do we call that? Intercept? What? Intercept? Not intercepts. That would be if it was where it was passing through the x-axis. Well, we have two graphs, and we're looking at where one graph passes through the other graph. What's that called? Oh.
Intersection.
An intersection. There are points of intersection. Yeah? So, notice where are our first 2 points of intersection? They're labeled.
Pi over 6.
And?
Pi over 6.
Do those look familiar? There are the unit circles. Guess what? We're going to be using this unit. The unit circle. Okay.
Okay.
So, if we recall back to our unit circle, we can kind of think about where does sine equal 1/2. Well, it equals 1/2 at pi over 6 and 5 pi over 6, right? Which also graphically we can see that. Is that going to be the only place where sine equals 1/2? Why not?
Because the sine graph keeps going.
But also, like, it doesn't just keep going, right? Like, all of our graphs keep going, but as it keeps going, what happens to it?
It keeps crossing over pi.
Yeah, it keeps, like, repeating itself, yes? No, maybe? So how many solutions are we actually going to have? An infinite amount. How do we write out an infinite amount of solutions? Dot, dot, dot with what?
Why can't you just list like the 3 solutions you can see?
You know, like AN at the end or something? Like A sub n,
There is going to be an n, agreed.
like X sub n,
So how do I get my next 2 solutions?
You added 2 pi.
Why 2 pi?
That's the 3.
Correct. So then how would I get my next solution?
Add 2 pi.
2 pi.
Okay, so how many 2 pi's would that be?
4 pi. 2 pi's.
2 pi's, right? And if I added another 2 pi, that would be,
3 pi's.
and so forth, right? But if we go backwards, we are subtracting 2 pi. Yes? Okay. So can we just say that we can basically add or subtract an infinite number of 2 pi's?
yeah.
Okay. So we can represent that, like you said, with an n. So we're going to have 2 n pi, where n is an integer. So remember, integers can be positive or negative, so that accounts for both adding and subtracting. So we list our first 2 solutions, like in our first rotation of our unit circle, and then we're going to add a 2n pi. And those will be our answers. What questions do we have there? Yes, or maybe. said, for the most part, just like with any of our functions, we don't tend to like to solve them graphically because it just takes a lot of time, and there's some stuff that's not super easy to solve graphically. So for the most part, we're going to use some different algebraic techniques. Okay, all of our algebra stuff still applies, so we can still add things to both sides, subtract things to both sides, multiply, divide, all of those fun things. Sometimes we might have to combine like terms or factor, but in general, we are trying to isolate the trig function. That way, then we can go backwards and use our unit circle. Yes, no, maybe. So if you don't have your unit circle memorized, I might get out your handout that we did that filled in the unit circle so you can look over that. However, I would suggest making sure that we know that by our test day. Alright, you ready for an example? Alright, do I have an equation here?
Yeah.
Yeah, what does it equal? 0. Do I have a trig equation?
Yeah.
Yep.
Square root of 3
Okay.
and divide by 2.
Yeah. So we would want to add square root of 3 to both sides. And then divide by 2 to both sides. And does the square root of 3 over 2 look familiar?
Yep.
Yeah.
It should. What is it?
60 degrees. That was a guess.
It's on our unit circle.
Wait.
Yes?
Second quadrant.
So we're trying to figure out where cosine is equal to square root of 3 over 2.
Blocking in it.
I think it's just cosine.
Cosine is our x value. So that means where is cosine? Too much.
30 degrees.
It's at 30 degrees. Let's put it in radians, please.
5 over 6.
Pi over 6 is at the only place.
11 pi over 6.
Okay, why 11 pi over 6?
As it's also cosine is
Yeah, but where is 11 pi over 6?
the fourth quadrant.
Okay, and cosine is
Positive in the fourth.
positive in our fourth quadrant. Yes? Do we remember where our trig functions are positive and negative?
Marker glass.
No? Okay, we would like to be reminded where they're positive and negative.
They're all positive in the first.
They are.
Sine is positive in the second.
It is.
Tangent is positive in the third, and cosine is positive in the fourth.
Yeah,
It's marker class.
correct. So remember that since x and y are positive in our first, all of our trig functions are positive. In our second, x is negative, but y is positive. So remember, since y is our sine value, sine ends up being positive. In our third, both x and y are positive, which means that sine and cosine are negative, but since tangent is sine over cosine, it ends up being a negative divided by a negative, which is a positive. And then in our last, since x is positive but y is negative, cosine ends up being positive in our last one. So we do get two different spots. So we said that our first spot is going to be at x equals pi over 6. And again, remember we're going to add our plus 2 and pi. And then our second spot in our fourth quadrant, so it has to have a reference angle of pi over 6, but be in our fourth quadrant. And we will also add a plus 2 and pi.
So is that plus 2 and pi, and then just go for everything when you're solving the trig function?
Most of them. Are there any that it won't be plus 2 and pi?
Yep.
Which one?
Tangent and cosine.
Ah, what would we add for those ones?
Pi.
Yeah, it's just going to be in pi instead, because they have a different period. Good question. Other questions? You ready to try one on our own?
How's it convert between radians and all that? Forgot. Never wrote it down here.
To convert from degrees to radians,
Yeah.
you're gonna multiply by pi over 180.
Okay. And then it's the reciprocal the other way around.
Right, if you're trying to if you're trying to convert from radians to degrees, it's 180 over pi.
Okay.
Okay.
What is this equal?
You get an answer there? Hmm?
Who's overclocked?
Don't murder yourself. So it looks like most of us were able to see that we need to subtract 4 and then divide by 8, which is also equal to negative 1/2. I think most of us got there. Then what we gotta remember is trying to figure out where to sign equal positive 1/2. We just talked about that a minute ago. Where does sign equal positive 1/2? Pi over 6, okay? And sign is negative in the which quadrants?
Negative in the which quadrant?
Third and fourth.
So it was a question, like which quadrants is sign negative in?
Third and fourth.
The third and fourth. So what are our angles that have a reference angle of pi over 6 in our third and fourth?
7 pi over 6 and 11 pi over 6.
So 7 pi over 6 and 11 pi over 6.
It's been so long since I've done this.
Which is why we're reviewing it.
You find the reference angle by adding it by 2 pi, right?
I find the reference angle by just looking at the positive version in my first quadrant. So sine equals 1/2 at pi over 6 in my first quadrant. So my reference angle is just pi over 6.
Oh, okay.
And then remember, like in our second quadrant, it's the bottom minus 1, so you get pi over 6. In our third quadrant, it's 1 plus the bottom, so we
Oh,
get 7 pi over 6. And then in the fourth quadrant, it's 2 times minus 1. So
Oh, so it's
12
that
minus
thing.
1.
I remember.
But don't if you add 2 pi, like, doesn't it get 7 pi over 6? Or at least the first one? Because out negative or like when it's
You have to add pi.
You have to add pi? I thought it was 2 pi.
You're talking about from my first angle, from pi over 6?
Yeah.
From pi over 6, right? That angle from my first quadrant to my third quadrant would be 180, which is pi, not 2
Oh,
pi.
that's fine.
To add 2 pi would get me all the way back to where I started.
Oh, okay.
Yeah, does that make sense?
Yeah.
Let's look at another one. What we have going on here? We got a tangent and we got a squared. So what do we want to get rid of first?
The 1.
How do I know to get rid of the 1 first?
Something like
We want the tangent by itself.
Because we want the tangent by itself. But like, why do I deal with the 1 first instead of the 3 or the squared?
Because you can't do anything with those yet.
But why?
Because you have to take them out of the 1 too.
So if I wanted to divide by 3, I had to divide
0 on the other side by 3.
as well as
1.
1.
1 by 3. I had to divide everything by 3. Yeah? that we do it in that order for solving.
Oh wait,
Dang.
dang.
What
I thought it was the opposite.
It is. So when we simplify,
Okay.
we use our order of operations. But if we are solving, subtraction and addition comes first, which is why we gotta get rid of that one first. Then multiplication and division. So what do we want to do next?
Divide by 3.
Okay. And then lastly, we can do our exponent. So how do I get rid of a squared?
Square root.
Root both sides.
Square rooted. What do we have to worry about when we take the square root of something?
It being on the bottom.
Yes, like if that was our final answer, we tend to not like our square roots to be on the bottom. But remember, I still have to solve for x. So we're not going to quite worry about that square root on the bottom yet. But there is something else that we do have to worry about.
It's 10.
It is tangent. So like if I had 4 and I took the square root, what do we get?
2.
Okay. Is 2 the only thing that if I square it, I get 4?
No.
What else squared gives me 4?
-2.
Which means,
Absolute value.
not quite. I want both answers.
Oh,
So I need to add a plus or a minus to the front of that.
like with the quadratic.
Yeah, like when you have x equals negative b plus or minus, that's what gives us those two options. Which, because technically this is a quadratic, it's just the quadratic trig, right? So I still have to have my plus or minus there. So now let's think. Tangent is not on our unit circle, okay? But is there a way for me to rewrite tangent with stuff that is on our unit circle?
Yes.
Yeah.
How do we rewrite it?
Sine over cosine.
Okay. Now, remember that when sine is 1/2, cosine is square root of 3 over 2, and vice versa. When sine is square root of 3 over 2, cosine is 1/2. So our 2's are always going to reduce out. Yes? And it just ends up mattering where our square root of 3 is, if it's on the top or the bottom. So right now, for this tangent, our square root of 3 is where? And for our tangent, cosine is what's on the bottom. So where does cosine equal square root of 3 over 2? Pi over 6. Okay. Yes. Yeah, I agree. And what are we adding this time?
Pi. And pi.
In pi. Okay. Which also means if we think about that's here, right? So if I add in pi or if I just add pi, where does that put us? In the third quadrant, right? So we actually don't have to write the second angle where tangent is positive because my plus in pi takes care of that. Yes? However, we also have a what here? That negative, so when is tangent negative?
Second and fourth.
Second and fourth, so what is the angle in our second quadrant that has a reference angle of pi over 6? Okay, and then by adding in pi again, that takes care of the one that's in our fourth quadrant. What questions do we have there?
There's always only 2 answers, right?
There's always going to be what?
Only 2 answers that we can put.
Always is a strong word.
Most of the time.
So like for tangent, if I didn't have that plus or minus, how many of answers would we have gotten? One. Right? Because that in pi takes care of both the positive or both the negative. So I would say usually more likely than not with our tangent and our cotangents, we're only going to have one solution. With our sines and cosines, yes, we'll usually have 2 solutions. We are going to look at on Monday what happens when we have stuff on the inside of the x, and in those cases, we can get more than 2.
It's like, you scared of the tangent? Well, you're not scared of the whole one third.
You would. But and remember, when I take the square root of things that are being divided, I'm allowed to divide the top and the bottom separately. So I just have the square root of 1 divided by the square root of 3. The square root of 1 is just 1, and then I have square root of 3 in the bottom. So you would. So like if it was like a 2/3, then yeah, you would have the square root of 2/3. That one wouldn't reduce. Good question. I just did that all in one step. Other questions? Alright. Ready to try another one? What do we have here?
Oh, no.
It's not as bad as it looks.
Looks very bad.
What makes it look bad?
There's too many squares there.
Cotangent.
There's too many cotangents.
I was like, we only have one square, so there's not too many squares, but we do have 2 cotangents, alright. And then what else is happening with those cotangents?
Should we, one thing will go back to the
Yeah, one's being multiplied to that cosine squared. What else? Where are my 2 cotangents located?
On opposite sides.
Ah, okay. So thinking back to like our algebra days, whenever we had stuff on both sides of our equation, what was it usually helpful to do?
same side.
Get everything to the same side. Agreed. So how would I get everything to the same side?
Divided by cotangent.
Disagree. Why am I not allowed to do that? Okay.
Is it because cosine squared?
No,
Why can't do it? Oh.
that doesn't really affect it. So like, let's say I had something like that, right? So similar to what we have x's and y's instead. Agreed? Can I divide by an x there?
Yeah.
I thought you could.
Nope, you can't.
Oh, wait.
Why?
Why not?
How have we solved those in the past in this class?
Oh, are you supposed to move the like 2x to the other side and make it equal to 0?
Correct. And
Oh.
we would then
Come on. I just lied.
Effective.
correct.
Oh.
So why do I want to do it this way, which is how we're supposed to do it, instead of dividing everything by an x?
So that you're not getting rid of an x.
Okay, why can't I get rid of an x?
Because I changed the thing.
It changes the value of the equation.
Not if I divide both sides. Doesn't change the value. It has something to do with a value though.
Not the right thing to do.
Well, why? That's what I'm asking.
Because it's easier and they made it to where they want everything to be harder.
No. So thinking about division, right? We're talking about dividing by x, yes? When we think about division, do we have any things or rules that apply when we have division?
Can't divide by 0.
Ah. Is there a chance that x could be 0
Yeah.
in my equation?
Oh.
So could we potentially be dividing by 0?
No.
Which is why, when I factor it, notice now, we would set both of our factors equal to 0 instead. And we do get x equals 0 as one of our solutions. So if you divide out that x, you're basically getting rid of one of your solutions. You with me?
So let's say.
So same thing here. I have a cotangent on both sides, right? My cotangent graph has x-intercepts, which means it goes through 0. So there are spots where our cotangent equals 0. So if I divide by a cotangent, I am dividing potentially by a 0, which we're not allowed to do. But using the same idea as what we did here, what could I do instead to my equation? Okay. I can't factor out an x, because remember, all of our x's are technically inside of our trig functions.
Factor out the cotangent.
But I can factor out the cotangent, because they both terms are sharing a cotangent. Yes? Then what can we do?
Set them equal to 0.
Okay, and cotangent is what over what?
Cosine over sine.
Cosine over sine. So which one of those is allowed to be 0?
Cosine.
Cosine. So where's cosine equals 0? And I'm going to add almost.
Well,
Cool. And whenever we take that square root, what do we have to worry about? Plus or minus. Now, is the square root of 2 on our unit circle?
Mm-hmm.
It is? Just the square root of 2?
No.
Oh, no.
No, we have a square root of 2 divided by 2. Okay, but we don't have a square root of 2. So we can't just use our unit circle this time to go backwards. However, what else have we talked about that like undoes or gets rid of trig functions? What's like the opposite of a trig function? An inverse trig function. Because remember that if I have an inverse of a trig function, those two things undo each other, and we're just left with the x. But I can't just take cosine inverse of one side. We would also have to take cosine inverse of the other side. But because that's not on our unit circle, we would just plug that into our calculator. So we would type in cosine inverse of the square root of 2, and tell me what you get.
Oh, that's mine.
What do we get?
Error.
Why?
Because it doesn't work.
Why?
Because the calculator said it.
Because what?
Everyone
So remember that our sines and cosines, right? Our cosine starts at what? 1, and it goes down to negative 1. Does it ever get bigger or smaller than 1 and negative 1?
Nope.
No. Which means that once we started looking at something, where does cosine equal? Square root of 2 is going to be approximately like 1.4-ish. Is there ever going to be a spot where cosine can equal 1.4-ish?
No.
Not really. So what would we say there? Yeah. If it's a solution, if it's a equation, what do we usually say though? No solution. So that one cannot be solved. So we would just end up with our first answer. What questions do we have there? Alright, we are going to stop there for today.